Welcome back. This is section 7.4, basic trigonometric equations. So what we're going to look at in this section now is how can we actually use some of these identities that we've been learning about to help us solve equations that involve like thetas and phis and things like that, some of these variables that we use for angles. All right, so our first equation, we want to solve the equation sine theta equals 1/2. Now, in general, we know to get rid of a sine, we're going to use its inverse. And so we're going to take the inverse sine of both sides of this equation. So I'm going to say inverse sine theta is equal to inverse sine of 1/2. Now, remember, the inverse sine and the sine should cancel each other out. That leaves us with our theta. And now we just need to think about what is the inverse sine of 1/2. So again, we're thinking about on our unit circle, where would we have a sine value that is equal to 1/2? And the place that that's going to happen is going to be pi over 6. Now, in general, when we talked about inverses before, we always said that our values needed to be somewhere between negative pi over 2 and pi over 2, just to make sure that the domain of our inverses worked, right? Now, with these, when we're solving equations, we actually want to make sure we're finding all the possible solutions to these equations now. So not only do we have to worry about pi over 6, we have to think about where else would the sine be equal to 1/2. And if you think about your unit circle, we know that pi over 6 is going to be right down here. But we also know that sine is going to be positive in the second quadrant. And so we have to consider this value over here at 5 pi over 6, because the sine of 5 pi over 6 would also be equal to a positive 1/2. Now, in addition to those two values, we also have to consider the fact that we could just do full revolutions beyond each of these values, and those would also have the same sine value. And so for both of these, I'm going to have to add 2 pi. But I could add 2 pi as many times as I want to. And so we're going to use some constant value here as just a multiple that we're multiplying by for that 2 pi. So all of our solutions to this equation would be pi over 6 plus some multiple of 2 pi k, or 5 pi over 6 plus 2 pi k. Again, in addition to just finding that one value that we would normally find for inverse sine, we also have to consider where else on our unit circle would we have a sine value that's equal to that. And because we could have full revolutions beyond that, we have to put that plus 2 pi k for each one of our solutions. So for this one, all of this right here is the answer. And we can see here, right, this is just showing us our unit circle, right, where we would have a value of 1/2, and the fact that because sine is periodic, right, we have more than that one solution. There's actually an infinite number of solutions beyond pi over 6 and 5 pi over 6, where we would hit those same values of 1/2. All right, now our next one, we've got cosine theta is equal to negative square root of 2 over 2. So again, we're going to use our inverse to solve this. So we take the inverse cosine this time. And if we do that, that's going to give us theta equals inverse cosine of negative square root of 2 over 2. So because cosine is negative here, we know we're going to be either in the second quadrant or the third quadrant. And those two values are going to be 3 pi over 4 or 5 pi over 4. So again, just thinking about where would cosine be square root of 2 over 2, where would it be negative in the second and third quadrants. And so we get those two values now. And just like with our inverse sine, because we could also have full revolutions on top of that, we have to make sure we add 2 pi k to both of these solutions. And so this right here is going to be our final answer. And so unless it says a specific solution or tells you a domain like between 0 and 2 pi, we have to assume that they're looking for all the solutions. And so we have to do that. Now, once we've solved it, it also asks us here to list 8 of our specific solutions. So I'm going to start by just 3 pi over 4. That's one specific solution. I also know that 5 pi over 4 is another one, right? So I've got 2 of my specific solutions already. Now, to find the next one, we can just add 2 pi. So I'm going to take 3 pi over 4 plus 2 pi. To add those, I need a common denominator. So that's going to be 3 pi over 4 plus 8 pi over 4. And so that's going to give us 11 pi over 4. And so 11 pi over 4 is another solution that would work. I can do the same thing with 5 pi over 4. So again, just adding 2 pi. Common denominator gives us 8 pi over 4. And when I add those together, we should get 13 pi over 4. Okay, so far I have 3 pi over 4, 5 pi over 4, 11 pi over 4, 13 pi over 4. Now, because we're adding some multiple of 2 pi, I could actually make that a negative value of 2 pi as well. So I'm going to actually subtract 2 pi and get some negative angles that could work. And so if we do that, we have 3 pi over 4 minus 2 pi. Again, our common denominator is going to give us 8 pi over 4. And so negative 5 pi over 4 would be another angle that would work here. And then we can do the same thing with 5 pi over 4. We subtract 2 pi. Common denominator gives us negative 3 pi over 4 as our answer here. Okay, so there's 6 specific values that would work. And so if I want to find 2 more, I'm just going to go back to like the 11 pi over 4 and 13 pi over 4 that I had already found. I'll add another 2 pi to that. So 11 pi over 4 plus 2 pi. Again, we're adding 8 pi over 4. So 19 pi over 4 is one more solution here. And then finally, if we do the 13 pi over 4, add another 2 pi to that. That should give us 21 pi over 4. Okay. And so now I've listed out 8 specific solutions. And so if you have any in the homework that asks for 8 specific solutions, it really doesn't matter which ones you list, right? I could add 2 pi more to each one of those, right, and get 2 more answers that actually work. I could even subtract 2 pi from my negative values and get 2 more answers that work. So as long as you're listing out 8 specific ones that actually are solutions to this equation, then you should be good. And again, here they just give us the graph just to show us, right, that at 5 pi over 4 and 3 pi over 4, we would have that negative square root of 2 over 2. And again, because cosine is periodic, it's going to hit that value an infinite number of times, which is why we need that plus 2 pi k. All right, now the next one here, we've got cosine theta equals 0.65. Now, 0.65, not one of our special values, right, that we're familiar with. So in this case, we are going to have to use a calculator. So I'm still going to just take the inverse cosine of both sides. And I want to make sure my calculator is in radian mode. But if we do our inverse cosine of 0.65, that should give us 0.86 now. Now, if you recall on the last one, right, we had 2 different values that would work there. And so the same thing is going to be true here, but our calculator is only going to give us one of those values. So it's up to us to find the other one that's going to work. So the way I'm going to do that, think about my unit circle. And I need to figure out where is 0.86 located. Well, the way to do that is to think about these key values along the axis and what their decimal approximations would be. So I know that pi over 2 is about 1.57. Well, 0.86 is smaller than that, so that means that 0.86 is actually going to be in the first quadrant. Well, since I had a cosine value that was positive, I know the other place that I could have a positive value for cosine is in the fourth quadrant. And so I need to look down here at this point. To find the value of that now, I know this distance is the same as the distance up here in the first quadrant. So I can just do 2 pi minus 0.86, and that should give me the other value that would work here. Okay, and so that should, if we put it in the calculator, give us about 5.42. So my other value that's going to work, 5.42. And just like before, there's technically an infinite number of solutions that would work here. And so we have to add 2 pi k to each one of these. Now, another way to think about this is that because our value in the first quadrant is 0.86, we could have also just said, well, this should be the same distance, but in the negative direction. So we could make it a negative 0.86. If you wanted to write this answer that way, that's perfectly fine, because negative 0.86 plus 2 pi k is exactly the same as 5.42 plus 2 pi k. Because if I just add 2 pi to the negative 0.86, it's going to give me 5.42 anyway, right? So that'll give me exactly the same solution. So if I will take it either way that you want to there, just make sure that you're finding that second one somehow. And again, here we can see, right, 0.86 in the first quadrant, and so we have to make sure we put the other one in the second quadrant, or sorry, in the fourth quadrant, so that gives us the 5.42, and then again, because it's periodic, we have to make sure we have the plus 2 pi k. All right, now our next example, we've got tangent theta equals 2. Now again, 2, not a special value from our unit circle, and so we are going to have to use a calculator here. This time we're doing inverse tangent. And so if we go to our calculator and do the inverse tangent of 2, it should give us about 1.12. Now, what's nice about tangent is the period of tangent is actually pi. And so unlike sine and cosine, where we had to find a second value, in this case, we only actually need to find the one value. And instead of adding 2 pi k, we're just going to add pi k. And the reason we can do that is if we think about where this is located now, we just said that pi over 2 up here is about 1.57. So we're still smaller than that, right? So we're in the first quadrant. The other place that tangent would be a positive would be in the third quadrant. So it would be right down here. Well, the way I'm going to get that value, I know this is pi right over here. So this would just be pi plus 1.12. But notice 1.12 plus pi k is going to give me that value anyway. And then if I add another pi to that, now I'm back in the first quadrant. And if I just keep adding pi, I'm going to keep hitting those two same values. So that's why we don't have to find the specific value in the third quadrant. Just adding pi k is going to take care of that one and all of our revolutions also. And again, the reason we're allowed to do that is because the period of tangent is pi, and so we only really need to find one solution and then just add pi k to that. All right, now these next examples, we're going to have to do some manipulating first before we can just do our inverse to get the theta value. So if you can isolate the trig function, that's always the way you want to go. So notice with this first one, I have a sine theta in there. I need to try to get sine theta by itself, and then I can use my inverse and solve the same way we have the others. So first step, I'm going to add the 1. So we get 2 sine theta equals 1. I'm going to divide by 2. Sine theta equals 1/2. And now I'm going to do my inverse. So theta equals inverse sine of 1/2. And this is actually exactly the same as that very first example that we did. So if you recall the inverse sine of 1/2, we got pi over 6 and 5 pi over 6. And again, if we want all of our solutions, we need plus 2 pi k on each one of those now. So again, if it's possible to isolate the trig function, get it by itself, do that first. Then you can use your inverse, and then we're going to solve the same way we have before. All right, now this next one, same thing. I only have one trig function tangent. I'm going to try to get it by itself, so I'm going to move the 3 over. So we get tangent squared theta equals 3. Now this time, to get tangent by itself, I need to take the square root of both sides. Now remember, when we take a square root like this in an equation, we're going to get a positive and a negative value for that answer. So we're going to get a plus or minus square root of 3. So really, we're trying to figure out where is tangent positive square root of 3 and where is tangent negative square root of 3. So tangent theta equals square root of 3, or tangent theta equals negative square root of 3. Now we do our inverse. So we get theta equals inverse tangent of square root of 3. And over here we get inverse tangent of negative square root of 3. Now we think about our unit circle. We think about where tangent is equal to square root of 3. And that's going to happen at pi over 3. So we get theta equals pi over 3. And again, we only need the one value here because we know the period is pi, so we can just add pi k to that. Okay, now we need to think about where tangent is equal to negative square root of 3. And you've got two options. We need to think about our second quadrant or our fourth quadrant. I'm going to go with the value in the second quadrant here. It's going to be 2 pi over 3. And again, because the period there is pi, we have to add pi k. And so for this one, we're going to get both of these as our answer, okay, because we needed both the positive square root of 3 and the negative square root of 3 this time. And again, if you had chosen to use the angle 5 pi over 3 in the fourth quadrant for that second piece, that's perfectly fine. You just need to make sure you're choosing either the angle from the second or the fourth quadrant, since we want a negative square root of 3 there. All right, now this next example, okay, we're trying to solve this equation. Now notice we're not going to be able to just get cosine by itself because I have a cosine squared and I have a cosine. There's no way just to isolate the cosine here. But it actually is in a quadratic form. Okay, so if you remember when you took algebra, actually seeing things like this, I'm going to change cosine theta to an x value just to make it look a little more familiar to something you might have seen before. So everywhere I see a cosine, I'm going to replace it with an x. And so this is going to become 2x squared minus 7x plus 3 equals 0. And so we can see now this is just a quadratic equation. We're setting it equal to 0, and now we need to solve it. Now remember, we've got a few options in terms of solving quadratics, right? Quadratic formula is one of those options. That's always a good way to go if you're not sure how to do anything else. You could complete the square. That's another possibility. Or if it factors, that's probably going to be the quickest way to do it. In this case, this one does factor, so that's what I'm going to do. I'm going to factor this. I'm looking at my factors of 2x squared. That's going to be 2x and x. Now I'm looking at my factors of 3. That's going to be 3 and 1. And in this case, I'm going to put the 3 with the x, the 1 with the 2x, just because I know I need to multiply 2x times 3 to get 6x and 1 times x to get 1x. That way I get a 7x in the middle. And because it's a negative 7x and I need a positive 3 when I multiply, both of these signs are going to be negative. Now, once we've got it factored, to solve this, I'm going to set each one of those factors equal to 0. So we have 2x minus 1 equals 0, and we have x minus 3 equals 0. Now I'm going to solve for x, move the 1 over, we get 2x equals 1. Divide by 2, x equals 1/2. And for the other equation, I'm just going to add 3, so x equals 3. Now, remember, x is just cosine. And so in place of x now, I can say, well, this is just cosine theta equals 1/2. And over here, we just have cosine theta equals 3. Now, from there, I can do my inverse. So I'm going to do theta equals inverse cosine of 1/2. Again, because it's a cosine, there should be two values that we have to worry about. Because it's a positive value, that's going to be in the first or the fourth quadrant. The one in the first quadrant should give us pi over 3. And the one from the fourth quadrant is going to be 5 pi over 3. And because we're looking at all solutions, we have to add 2 pi k to both of those. Now, for the second equation, if I do my inverse, right, 3 is not a special value. I would have to go to the calculator to do this. However, remember that the domain of our inverse cosine has to be between -1 and 1. This actually is not going to give us anything. And so this is actually an undefined answer. So our only solutions to this one are going to be right down here. But just keep in mind, if that had been defined, then we would also need to include whatever values we get from that factor in our final answer as well. And again, this is just kind of showing us, right, those are the two places where we would get 1/2. And that's how we got pi over 3 and 5 pi over 3. And again, adding the 2 pi k because of the periodic nature of cosine. All right, now our last example from this section, we got 5 sine theta cosine theta plus 4 cosine theta equals 0. Now again, I recognize I'm not going to be able to just get my trig function by itself because I've got, first off, multiple trig functions, both sine and cosine, right? And they're in multiple terms, so there's no way to just isolate them. So I'm going to look at ways that I might be able to solve this. I notice here that both of my terms have a cosine in common. So there's a common factor this time. That means I can factor out the common factor. So I'm going to take out a cosine theta. So cosine theta. If I do that, what's left in that first term is going to be 5 sine theta. Plus, and if I take out a cosine theta from 4 cosine theta, now I'm just left with 4. Now that it's factored, just like before, we can set each factor equal to 0. So we're going to have cosine theta equals 0, and 5 sine theta plus 4 equals 0. Now, this first one, I can just go ahead and take my inverse. So theta equals inverse cosine of 0. And if we think about where cosine is equal to 0, there's two places where that would happen, where that x value is 0. That's going to be pi over 2 or 3 pi over 2. And again, with cosine, our period is 2 pi, so we have to add 2 pi k to both of those. Now, to solve the other piece, I first need to get sine by itself. So I'm going to subtract 4. So we get 5 sine theta equals -4. Divide by the 5. So we get sine theta equals -4/5. And now I do my inverse. So inverse sine -4/5. Now, that's not a special value, right? So we are going to have to use the calculator for this one. If I use the calculator, theta equals -0.93. Now, I still need to think about the other value where that would be true, right? So again, I'm going to think about my circle here. We know we have a negative value for sine this time. We got -4/5. The -0.93 is right down here in the 4th quadrant. Well, the only other place that sine is going to be negative is going to be in the 3rd quadrant. And so I'm looking for this point right over here in the 3rd quadrant. Now, the easiest way to do this, I know this distance should be the same as this distance from the x-axis. I know that this value here is pi. That distance is 0.93. And so if I just do pi plus 0.93, that should give us the other value in the 3rd quadrant now. And if we do that, we should get 4.07. So my other value, 4.07. And as always with sine, we need a plus 2 pi k if we're looking for all of our solutions. And so this time, we get these solutions from the 1st factor, we get these solutions from the 2nd factor, and so all of that is part of our final answer. Now, just so you see, we could actually combine those first 2 solutions from the inverse cosine of 0, because if I just wrote this as pi over 2 plus pi k, this is actually going to give us all of our solutions that we need, because pi over 2 plus pi would hit 3 pi over 2 anyway. And then when I add pi again, I'm going to be back to pi over 2 where I started. And so actually, this solution is a little bit cleaner. I will take either one, but just know that if you ever see it written in that bottom form, those 2 things are equivalent. All right, so that's all we've got for 7.4. As you're working on the homework, as always, send me questions if you have them, and I will see you next time.